for analytic function. For an analytic function, u is given, we have u, we have to find the value of v. So we can assume, we can find with the help of CR equation, Cauchy-Riemann equation, we know very well, because if any function is said to be analytic if ux is equals to vy and uy is equals to minus vx, yeah, we know that. We can approach with the help of this one. What we are having as u is equals to 3x square minus 3y square, we are having, yes. Let's find the del u by del x from here. It will be 6x. Let's find the del u by del y from here. It will be minus 6y, right? So let's take option one by one. When we approach to the option number A, when we approach to the option, I think we already discussed this question, and according to me the answer will be this one, but still let me check. I'm not sure about this one, let me check. So when we check the option number A, it will be 3y square minus 3x square plus k. We have to find the, if this is v, the partial differentiation with respect to x is minus 6x. I want ux is equals to vy and vy is equals to 6y. So ux is not at all equals to vy, so it's not possible. I think the answer is D option. Let me check directly D. If we already did the question, then answer might be possible D. So if this is v, let's approach the partial differentiation with respect to x. It will be 6y only, yeah, ux is equals to vy. So it will be 6 ux is equals to vy, yeah. So this is my ux, it should is equals to vy. Okay, let me find out vy first now. It will be 6y on 6x only, yes, exactly. So it will be equals to vy, yeah, and uy is equals to minus vx. Let's find the vx. It was 6y, so it will be vx only, yeah, exactly. It's satisfying the condition, so the answer will be this one. So dear students, sorry, but as I think so it's already repeated question, but still you can approach, don't worry, it's a GATE problem only. Done. So we already approached this question, as I think so. Okay, now which one of the following is the residue of the above function? So we have to find the, we have options as, so which one of the following is the residue? So let's approach which one is the residue. So we know very well the function is fz is equals to 9 by z minus 1 and z plus 2 whole square. Here we don't have any point, so we can find the residue at its poles only, right, at poles only. So let's approach to the pole. So residue of f of z, right, poles are what? Denominator is equals to 0. We are having z minus 1 is equals to 0, means the first pole is z is equals to 1. Second, we are having z plus 2 whole square is equals to 0. So we can say z plus 2 whole square is equals to 0. It will be z is equals to minus 2 and minus 2. Here we are having repeated pole. Here we are having repeated pole, right? So let's approach it. Let's approach it, guys. So residue of f of z is equals to limit at z is equals to 1. Limit z tends to 1, z minus 1. When we approach here 9 by z minus 1, z plus 2 whole square, it will be cancelled out. When we approach here, it will be 1 plus 2, that is 3 square. That will be 1 plus 2, 3 square, that will be 9. So it will be 9 by 9, which is equals to 1 only. So we don't have any option with the 1. Okay, so we can leave here. So we can check for the second also, residue at f of z. Here we are having the double order pole, z is equals to minus 2 we are having. So residue, it will be limit z tends to minus 2, d by dz at z minus 2, z plus 2 whole square into 9 by z minus 1, z plus 2 whole square. It will be cancelled out, yes, exactly, it will be cancelled out. So when we approach here, limit z tends to minus 2, it will be d by dz 9 by z minus 1. So we have to differentiate this one. We know the differentiation of 1 by x is minus 1 by x square, right? It will be minus 1 by x square. So we can approach here minus 9 by z minus 1 whole square, and the limit is already we are having as minus 2, limit is already we are having as a -2. So okay, is it -1? Yeah. Okay, it will be square, so it will be z d by dz, and the result will be like this only. Z tends to -2 when we approach here. Okay, let's check it what happened. So when we approach here, it will be -9 divided by -2 -1 whole square. It will be -3 square, so it will be -1. So according to me, the answer will be -1. We are having, yes, exactly -1 we are having, which is in the option number A. So we are having option A, which is the residue. So we are having we are having option A, which is the residue. Done, guys. Now let's approach to the next one. Now it's a good question. Consider the complex valued function fz is equals to this one, where z is a complex variable, the value of b for which the function is analytic. Now it's already written that the function is analytic. It means we have to go for the analytic function concept only. So as we discuss the questions related to analytical function, we can approach this question also. This question has been asked in EC 2016. So let's approach to the question. Guys. Okay, exactly here fz is analytic. What exactly question is talking about? The value of b. We have to find the value of b only here. Okay, I think there is a mistake in the question. Okay, let's have discussion later on this one. Now let's come to this one, residue. Here the next question is fz is equals to sin z by z square. The next question is fz is equals to sin z by z square, the residue of the pole at z is equals to 0. So we can approach here. Can we find the residue directly from here? Yeah, directly we can find. So residue at pole. So directly when you approach here, z square is equals to 0. It will be z is equals to 0 and 0. We are having double pole. Now here we have two options to approach the concept of residue. Why? Because if you want, then you can go with the expansion of the given function also. So let me show you. If you want to go, you can go with the expansion of the given function. Means we can approach the sign also. Let me show you, guys. Yeah. Okay. Yes. So we are having as z is equals to 0 and 0. The pole is double order pole. If we want to approach, we can write down the fz is equals to 1 by z square. We can write down the expansion of sin z. The expansion of sin z is nothing but sin x is nothing but x minus x cube by 3 factorial. We know very well. It will be z minus z cube by 3 factorial plus z 5 by 5 factorial and so on. Yes, exactly. We are having. Okay. So when we approach here, we can go with this one. It will be 1 by z minus it will be z by 3 factorial plus it will be z cube by 5 factorial and so on. Yes, exactly. Right. So here, as we know very well, the residue is nothing but the coefficient of as I already told you, the residue is nothing but the coefficient of z minus a to the power minus 1. Coefficient of z minus a to the power minus 1 in the Lorentz series expansion. So this is my series expansion. If I have to find out the residue, I can directly approach. My residue will be 1 by z minus 0, right? The coefficient of z minus 0, power minus 1. Here the coefficient of this one is z minus 0 power minus 1 is 1 only. So the residue will be 1. If you want to directly approach, you can go with this concept. If you want to directly approach, you can go with this concept that the answer is 1 only. Okay, right? As I already told you, the residue is nothing but the coefficient of z minus a to the power minus 1 in the expansion of Lorentz series. So here we already approached a series. right? In this series, if we find the coefficient of z minus a to the power minus 1, which is equals to 1, so we can tell that, we can say that the residue is 1. Okay, if you don't want to go with this method, we have second one also. Second one is that where we can find the residue, right? Where we can find the residue at the poles. So here, that's why I find out here. So we can say that let's find the pole. It will be 0 and 0. It will be double order pole. Yes, it will be double order pole. Yeah. So when we approach here, it will be double order pole. The function is fz is equals to sin z by z square. Now it's up to your choice. If you want to go with the expansion, okay, you can go with the expansion also. You can go with the expansion also, or you can go with the direct approach also. Means when you approach the sin z, the differentiation will be cos z, the cos 0 will be 1 again. Let me show you, right? So we know that the residue of f of z at z is equals to 0 when we are having double pole. It will be limit z tends to 0, yes. It will be d by dz, yes. It will be z minus 0 square, yes. Sin z, yes. Divided by z minus 0 square, yes. It will be cancel out. We have to approach z tends to 0 on this one. The differentiation of sin z is cos z only. So when we approach here cos z, the cos 0, it will be 1 again. So we can conclude the residue is 1 again. So if you want to go with this approach, you can go. If you want to go with the direct coefficient, you can go. Clear, guys? Okay. So one more question we are having. Yeah, exactly. We are having one more question. It's not exactly like this, but yeah, it's a good question of pole, means the residue also. The question is talking about for the function, for the given function we are having, we have to find the residue. We have to find the residue at its pole. So let me read out the question. This has been asked in the 2007 GATE examination 2007. So the question was yeah. Okay, so the question was we have to find the pole, or the pole. So for the function sin z by z cube of a complex variable z, the point z is equals to 0 is what? Z is equals to 0 is what? A pole of order 2, order 3, order 1, and not a singularity. So we can directly approach here that the function fz is equals to sin z by z cube we are having, yes. So we can approach here 1 by z cube as it is. We can approach here again the expansion of sin z, right? When we expand it, it will be z minus z cube by 3 factorial, z 5 by 5 factorial, and so on. So we can approach from here z square 1 by 3 factorial, z square by 5 factorial, and so on, right? So when we approach here, the result will be z square, means we have to find the order of the pole. So we can conclude here the order of the pole will be the order of the pole will be 2 only, dear students. So many students think that the order will be 3, but when we expand it, the order will be 2 only. We can see here the coefficient of this one, means the z minus 0 whole square will be 0. So we can say the pole will be of order 2. So that's why the result is the pole will be of the order 2 only. Clear? So we can conclude it, guys. Okay. So yeah, and let's have discussion on one last question. This will be definitely a good question of complex integration again we are having. So let's have discussion on one last question. This question has been asked in the 2010. The question is contour C in the adjoining figure is given, described by, means we are having a circle whose radius is a 4 and center will be 0 0. It means it will be 4 minus 4, it will be minus 4 iota, it will be plus 4 iota. So we have to find the value of this quantity. Guys. So let's approach it. So let's approach it. When we find the value of this quantity, the result will be, okay, this question has been asked in the 2010 GATE examination. Let's approach it. So we can say, okay, let me check the options. The options are right or not, because the options are repetitive. Okay, yeah, it's right. Okay, so let's approach it, guys. Now first of all we have to write down the function in a simple form. Let me write down the function. As we know very well, it will be fz. Okay, here I will approach with the help of okay, it's your choice, but I will approach here with the help of Cauchy's integral formula. Okay, so fz by z minus a, because it will be easy to approach. It's always is equals to 2 pi iota into f of a, that we know very well. Yes, so when we approach from here, it will be z square plus 8 divided by 0.5 z minus 1.5 j dz we are having, right? So as we know very well, the standard result is always in the form of z minus a. Here we don't have the standard form, here we don't have z minus a form, right? So we have to convert it in the standard form, guys, right? So let's approach it in a simpler form. So what we can do, we can write down here z square by plus 8, we can write down 1 by 2 z minus 3 by 2 iota. Okay, we can take common 2. Yeah, when we take common 2, it will be 1 by 2 z square plus 8, it will be z minus 3 iota. Now it's simple to approach. Yeah, exactly, now it's simple to approach. Okay, so 1 by 2 is there. Just remember one thing, the 1 by 2 is already here. Okay, so z square plus 8, we can find out the pole by putting the denominator is equals to 0. So the pole is z is equals to 3 iota. We can easily see it's lying between the range, because 3 iota is somewhere here, right? So because we are having on the imaginary axis, we are having the range as minus 4 iota to 4 iota. So we can say yes, it will be in the range only. So when it lies inside the closed curve, we can approach. The result will be 2 pi iota into f of a. Yes, so let's write down here fz will be z square plus 8. Let's write down here z is equals to a is equals to, we are having 3 iota. Yes, exactly. So when we are having 3 iota, we can approach here, guys. Okay, you can do the same question with the residue also, but right now I am proceeding directly. Okay, yeah, so a is equals to the point a is equals to 3 iota. Okay, so let's approach it. Okay, now so when we approach here, z square plus 8, do we have z square plus 8 only? Yes, it will be okay. So when we approach here, it will be close integration c, fz is what, z square plus 8 divided by z minus 3 iota. Yes, dz 1 by 2 is already here, it will be 2 pi iota into f of a, means it will be 2, when 2 is already here, it means it will be pi iota into f of 3 iota. Okay, when we approach here, it will be pi iota, and when we approach here 3 iota, it will be 3 iota whole square plus 8, it will be minus 9 plus 8, guys. Yes, exactly, we are having minus 9 plus 8. Yes, exactly, we are having. So it will be 2 into 2, 4, it's not cancel out, it will be 2 into 2, 4. So it will be 4 iota and minus 1 we are having. So minus 1, hence the result will be minus 4 iota. Hence my result will be minus 4 iota. So we can see the minus 4 iota will be the final answer. From here we can see the minus 4 iota will be the final answer. Okay, guys, right? This is the first approach. If you want to go with the residue theorem, I will show you the residue also. Okay, if you want to go with the residue theorem, you have to find the residue at the pole. So let me write down the function first for you. The function is just like this, z square plus 8 divided by 1 by 2 z minus 3 by 2 iota dz. If you want to go with the residue theorem, you can go with residue also. I think in this no one have difficulty, no one have any problem. We can easily approach from here, guys. Yes, okay. So when we want to approach here, so we can write down the result is again 1 by 2. It will be z square plus 8. The pole will be z minus 3 iota dz. So as we are having the pole is z is equals to 3 iota only, we can find the residue of f of z at z is equals to 3 iota. Limit z tends to 3 iota. 3 iota will be cancelled out. Still, let me write down z square plus 8. It will be z minus 3 iota. It will be z minus 3 iota. The result will be minus 1, and we are having already 1 by 2. So the result will be minus 1 here, and when we are having 1 by 2, it will be minus 2. So it will be minus 2 we are having, right? Because 1 by 2 is already there, so we can say it will be 1 by 2, right? Means 1 by 2 into minus 1 minus 2. So when you approach with the residue theorem, we know very well the integration fz dz is equals to 2 pi iota into sum of residues, right? So we are having 2 pi iota into minus 2 only, hence the result will be minus 4 pi iota. So if you want to go with the residue theorem, you can go, dear students. If you want to go with the Cauchy's integral formula, you can go. We can easily approach. So I think it's each and everything is clear to you, right? We discussed the complex variable already in a very detailed manner. We discussed each and everything related to complex. Either it is a basics of complex number, or it is analytic function, or it is harmonic, or it is means the pole, means the complex integration portion, right? Either it is Cauchy's integral theorem, Cauchy's integral formula, Cauchy's residue theorem, right? We discuss each and everything, guys. Okay, thank you.